All right, adding and subtracting radical expressions. So some things we already know, we're just going to take those things we know with us when we're talking about radical expressions. Now, if I had an expression like this, we already know that we're only going to combine like terms. So my linear terms and my constant terms and my quadratic terms, only the quadratic terms are going to combine. And then only the linear terms are going to combine. 2x. And only the constant terms are going to combine. Okay. Same here. So my quadratic terms that are squared, are going to combine. No linear terms, only constant terms. So I would have negative 2x squared minus 5x squared gives me minus 7x squared plus 4x squared plus 3x squared rather. So negative 7x squared plus 3x is negative 4x squared. And then we have plus 2 here. Okay, so let's say instead of x or x squared, let's now say that we're talking about radical expressions. So instead of just x, let's say I have, every time I have the square root of x, it's like the same thing. And then every time I have the cubed root of x, and we'll just say this is already by itself. So because these are the same, I can say they are like terms. Okay? So I can combine the negative 2 and the positive 4. Here, this is not going to change at all. Here, this is not going to change either. And then I can do the same thing here. So if I have radical square root 3x, square root 3x, square root 3x, these are all the same, like terms. Okay, so I can combine negative 2, negative 5, positive 3, and I can just keep this the same. My plus 2 is going to stay right here. So when we're adding or subtracting radical expressions, both the radicand and the index or root must be the same. All right, so let's say I give you an expression like this and I want you to simplify it. First, we need to simplify each expression or term. Okay, so 1, 2, 3 terms here. 3 terms in this example, just in case we forget. Okay, so 3. We're going to keep this as 3. Square root of 20. Now, hang on a second. This one has some factors that are perfect squares. Here, I've got a 2. This I can't simplify any further. So this whole thing became 3 times 2 with just square root 5 left over. I could do the same thing So this one right here, because it's the same, this just became 2. This stays 3. So I've got 3 times 2. I've got another square root 5 left. And then 45. Well, that's just 9 times 5. We know that the square root of 9 is 3. So here I've got a minus 3 square root 5. So now I'm going to combine any like radicals I have. So this is something square root 5, something square root 5, something square root 5. This makes these all like. So I'm just going to do 6 plus 6, 12, minus 3, 9 square root 5, final answer. Okay? Not so bad. Let's start with the things that we know. If I were to multiply 2x squared times 4y, I would find the numbers, and I would multiply them together. I would find each variable and multiply it together with each of its variables. So I would have a 2 times a 4, no change in the x squared, and no change in the y. Okay, so now when we multiply this x and the y, we didn't combine them because both of these terms have different bases. You'll also notice they have different powers. Exponents. Okay, so this y, we could say has an exponent of 1. Okay. If I do the same thing for number 2, I'm going to find my numbers, my x variables, my y variables, and I'm only going to multiply the numbers together. My x squared stays the same. My y squared stays the same. Now, because both of these variables have the same exponent, I could rewrite that as 15 x, y, with just the x and the y squared. Okay? Now you'll notice both of these have different bases, but they have the same power or exponent. Okay. Now when I compare to what's happening here, for examples 3 and 4, now we've gone from just expressions we're used to back to these radical expressions. So I'm going to still find my numbers, and I'm going to find all of my like terms. So instead of x squared, now we have square root of x. Instead of just y, now we have cube root y. So if they have different bases, meaning this one's an x and this one's y, I can't multiply them. My numbers I can multiply together. Now, I can't do anything because this is the only square root x. I can't do anything. This is the only cubed root y. So these two terms have different roots, which is the same thing as exponents. Just like we couldn't combine them up here. They also have different bases. Radicands. Just like they did up here. Okay? Here again, I'm going to find my numbers. Can multiply the numbers together. Now here, I've got a square root x. Here, I've got a square root y. So if I write this, taking the square root of x and the square root of y. Now this, if we think about this in exponential form, it's kind of like they have the same power, so we're rewriting it. So I can say this is the same thing as 15, and I can put both the x and the y in the radicand. Okay, so it's stuff that we already know. It's just making sure that we know it well enough not to get confused when we have radical signs. Okay, so here we have some distribution. We got some multiplication. So we're going to take this term and we're going to multiply it by both of these terms. So again, this example we don't have to, but I'm going to simplify all terms first. Okay, so can't really do any simplifying here. Now I'm going to multiply 3 times 5 square root x. So here are my numbers. My numbers come together. Here I've got a square root x. That's not going to change. Now when I do 5 times square root 3x, 5 is the only number. Now, I've got square root x, square root 3x. Both of these terms, x to the 1/2, 3x to the 1/2, both of these are being raised to the 1/2. So it's like I'm taking the square root of both of them. So I can simplify this as 5 square root 3. Now I'm going to multiply these together and I'm going to get this x squared. Now, square root of a squared, I can simplify this term right here. So this becomes 15 square root x square root of x squared. This is just going to be x. So I've got plus 5x square root 3. This is as far as I can go. Different radicands cannot combine. Once I'm done simplifying, I am finished.